Infinity is not a number like 17. Don't treat it as a number. Let me show you something that people do all of the time. Here it is. People write down the interval from 0 to infinity, including 0, which is fine, but including infinity, which is not okay. Infinity is not a number. What people should be writing down is this: the interval from 0 to infinity, including 0, but not including infinity. Because infinity is not a number. Why am I freaking out about this? What's so bad about thinking of infinity as if it were some number? If you start trying to do arithmetic with infinity, you're liable to walk straight into a trap. Let me demonstrate for you by walking into one of these traps myself. Let's treat infinity as if it were a number. Well, what's infinity plus 1 in that case? I got infinitely many things and I add one more. That's the same as having infinitely many things. So infinity plus 1 would equal infinity. Now, what else would I know about infinity as a number? Well, what would infinity minus infinity be equal to? This would be a number minus itself, and a number minus itself is 0. So if you're going to treat infinity as a number, you're going to be believing these two statements. You're going to believe infinity plus 1 is infinity, and you're going to believe infinity minus infinity is equal to 0. This is how these numbers would work. This is actually very bad. Let's just look at infinity plus 1 minus infinity. Let's subtract infinity from both sides. Now you said infinity minus infinity is equal to 0. But what's infinity plus 1 minus infinity? Well, that'd be infinity minus infinity plus 1. Infinity minus infinity is 0. This would be 0 plus 1. That side would be 1. So if you're going to treat infinity like a number, you're going to end up telling me that 1 equals 0. That's ridiculous. The upshot here is that you can't do arithmetic with infinity. Infinity is not a number like 17. But something comes to save the day. We can do limits. For instance, consider this problem where I'm doing a calculation involving infinity. But instead of working with infinity directly, I'm phrasing it as a limit question. What's the limit of x times x minus 1 as x approaches infinity? Well, x is as large as I like. By making x big enough, I can make x as big as I like. X minus 1 is also as large as I like. By making x big enough, I can make x minus 1 as big as I like. And what happens if I multiply together two numbers which are as large as I like? Well, the product of two numbers that are as big as I want them to be can be as big as I want them to be. So in that sense, the limit of x times x minus 1 as x approaches infinity is equal to infinity. So what about our original example? What's infinity minus infinity? Well, it depends. Here's one possibility. Let's consider the limit of x squared minus x as x approaches infinity. Now, this is a limit of a difference. You might remember back that the limit of a difference is the difference of the limits, provided the limits exist. Ignoring that last part about whether the limits exist, you might just blindly start writing down the limit as x approaches infinity of x squared minus the limit of x as x approaches infinity. This is no good, right? The limit of x squared as x approaches infinity, that's equal to infinity. And the limit of x as x approaches infinity, that's infinity. And I can make x squared as large as I like if x is big enough, and I can make x as large as I like if x is big enough. So what just happened? I'm writing the limit of a difference as the difference of the limits, but these limits don't exist. Right? They're equal to infinity, and infinity is not a number. Now I'm left with infinity minus infinity. I don't know what to do, right? Who knows what that's equal to? That's exactly the sort of thing I'm not permitted to think about. Instead, if I wanted to know the limit of x squared minus x as x approaches infinity, I could rewrite this limit as the limit as x goes to infinity of, what's another way of writing x squared minus x? Could write it as x times x minus 1. And we saw just a minute ago that the limit of x times x minus 1 as x approaches infinity is equal to infinity. So in this case, it seems that infinity minus infinity is infinity. On the other hand, infinity minus infinity could be 17. Let's see how. Here again, I've got a limit of a difference of two things, something minus something, as x approaches infinity. Now, if I blindly just apply the limit of a difference as the difference of limits without remembering that that's only valid if the limits exist, let's see what happens. Well, then I get the limit as x approaches infinity of the first thing, which is x plus 17, minus the limit of the second thing, which is just x. Now what's the limit of x plus 17 as x approaches infinity? Well, I can make x plus 17 as large as I like if x is big enough. So that's infinity. And what's the limit of x as x approaches infinity? Well, I can make x as large as I like if x is big enough. So that's also infinity. So I've again walked into the trap of writing down infinity minus infinity. Right? I applied the limit of a difference equals the difference of the limits without remembering that that's only valid if the limits exist. And in this case, the limits only exist in the weak sense that I can write down that they equal infinity. Anyway, don't want to do that. Now, how could I figure out what this limit's equal to? Well, this is a limit of something, and I could rearrange the something. Right? This is the same as the limit as x approaches infinity. What's another way of writing this? X plus 17 minus x. I could have just written 17. Now, what's the limit of 17 as x approaches infinity? Well, what's the limit of 17 as x approaches anything at all? That's just 17. So in this admittedly contrived case, infinity minus infinity ended up equaling 17.